Hi again, Fernando here, welcome to Binnacle Project. Let's do another stoichiometry problem, and on this occasion I want to give you the necessary knowledge to deal with this situation in which a substance is not given in grams but in the form of a dissolution. And not only that, the substance they are asking us to calculate will be given not in grams but in the form of a gas. So, what should we do? Please don't be scared at all. Working with chemical reactions involves facing situations like these, but as you will see in the following minutes, we will solve it very easily. So, let's go.
Binnacle Project.
Let's read together the statement. It says that 300 milliliters of 5 molar sulfuric acid solution is reacted with the amount of carbon needed to produce water, sulfur dioxide, and carbon dioxide. Section A says that calculate the volume of carbon dioxide obtained at 2 atmospheres pressure and 25 Celsius degrees. And Section B says calculate the volume of sulfur dioxide obtained under the same conditions. So the first thing we're going to do is to write the chemical equation. And it says that sulfuric acid, here you have it, this is sulfuric acid, reacts with the amount of carbon needed. Here, carbon. And don't forget that carbon is a monoatomic substance. In order to produce water, here's water, sulfur dioxide, and carbon dioxide. And the first thing we're going to do is to balance this equation. And as I told you previously, whenever you see a single substance, please leave it for last in order to avoid that horrible situation that when balancing an atom, another atom gets imbalanced. So let's do it. Let me recommend you to stop the video here and try to balance the equation by eye, but in case you can't do it, I'm going to do it mathematically. And even though it will take a few minutes, sometimes it's the unique way to balance the equation. And it will be very easy, so come with me if you want. We are placing these variables here, A, B, C, D, E, and we are using them to balance every atoms. So let's begin with hydrogen. How many hydrogen atoms do we have on the left side? 2A, that must be equal to 2C. Now it's turn for sulfur. A times 1 is A, must be equal to D times 1 is D. Now it's time for oxygen. A times 4 is 4A, that must be equal to C plus 2D plus 2E. And finally, carbon. B must be equal to E. And now we have a system of 4 equations with 1, 2, 3, 4, 5 unknowns. What are we going to do? Now we are choosing the simplest one, for example, second equation. And we are using this information to rewrite the other equations, which means whenever I find letter A, I will write letter D. So 2D must be equal to 2C. Here, 4D equals C plus 2D plus 2E. And finally, B equals E. And now we are doing the same. Let's choose the simplest one, for example, the third equation, in order to rewrite the other two. Well, we can remove these numbers from both sides, and D equals C, and here 4D must be equal to C plus 2D plus 2E. And last step, we are choosing this equation and we are using this information to rewrite the last one, which means instead of using variable D, I'm using C. For C must be equal to C plus 2C plus 2e. And now let's clean this equation up. 4c minus c is 3c. 3c minus 2c is c. That must be equal to 2e. And this is the last equation. And now let's give values to these variables. I think that the most interesting thing will be to, let's say that e equals 1. Thus, c equals 2. 2 times 1 is 2. And d must be equal to c. So d must be equal to 2. And b equals e. So b equals 1. And finally, a equals d. So a equals 2. And here we have the stoichiometric coefficients. I have already raised the previous calculations, but I've placed the stoichiometric coefficients on their positions. 2, 1, 2, 2, 1. And as you can see, the equation is already balanced. So now let's begin with the statement again. 300 milliliters of 5 molar sulfuric acid solution. So let me draw the situation for you. It says that the sulfuric acid is not coming in the form of grams, but in the form of a solution. It's a glass which contains sulfuric acid. There you have it, sulfuric acid, but also with water. And they are telling us that they are 300 milliliters of this solution, 5 molar. So what are we going to do? The most important molecule that we have to calculate is sulfuric acid. Water is an spectator molecule that doesn't matter in this problem. So let's try to calculate the amount of sulfuric acid that contains this glass. And as you probably know, molarity is defined as moles of sulfuric acid, in this case, divided by liters of the solution. So what are we going to do? It says that we have a 5 molar dissolution. 5 moles of sulfuric acid is what we want to calculate. And liters of this solution, 300 milliliters, which means 0.3 liters of this solution. 0.3. And thus we can calculate the moles of sulfuric acid that are floating in this substance. Using the calculator or doing it by eye, you can see that X equals 5 times 0.3, which is 1.5 moles of sulfuric acid. And there we have the amount of this substance in order to calculate the products. Okay? And now that we have already discovered the amount of sulfuric acid that reacts in the form of moles, it's time to read the statement in section A, which says, calculate the volume of carbon dioxide that is obtained at 2 atmospheres pressure and temperature 25 Celsius degrees, that I'm moving to kelvins just by adding 273. And if you do with your calculator 25 plus 273, you will obtain 298 kelvins. And look at this data. Don't you think that they are inviting us to use this equation? Pressure multiplying volume equals number of moles of carbon dioxide multiplying the Rydberg constant and multiplying the temperature. And this is the general ideal gas equation that will lead us to the solution. Please keep in mind that we don't need grams of carbon dioxide. We just need moles of carbon dioxide obtained. So having said that, let's bring the conversion factors to do 1.5 moles of sulfuric acid. And can you remember that the first conversion factor helped us to move from grams of this substance to move into moles of this substance? But we have already this substance in the form of moles, so we are not injecting the first conversion factor, but the second. The second conversion factor, as you probably can remember, helped us to move from moles of the substance that we are dealing with to move into moles of the substance we are interested in calculating, in this case, carbon dioxide. And there comes the stoichiometric coefficients, number 2 for sulfuric acid and number 1 for carbon dioxide. And as I told you previously, we are interested in calculating moles of carbon dioxide, not grams. So it's time to stop here the train, because here we will have already the solution, that is, the moles of carbon dioxide produced. Using your calculator, just do 1.5 divided by 2, and it gives us 0.75 moles of carbon dioxide. And this is the number that we are placing here. And we have pressure, 2 atmospheres. Multiplying volume, that is what we are asked to calculate. Number of moles of this substance produced, 0.75. Multiplying the Rydberg constant, 0.082. And multiplying the temperature, 298 kelvins. So now let's use the calculator, and we have 0.75 multiplying 0.082 multiplying 298 and divided by 2. Divided by 2, and it gives us 9.16 liters of carbon dioxide obtained under the given conditions. That's it. Well, how's it going? Easy, right? The first thing we had to deal with in this problem was that this substance was not given in the form of grams, but in the form of a dissolution, and we had no problem in calculating the amount of this substance in the form of moles or grams, but moles were enough to do this calculation. And we moved into moles of carbon dioxide, and here we stopped the train in order to obtain moles of carbon dioxide and place all this data in this formula, and we had the solution. Now we are going to do the same with the second section, as it says, calculate the volume of sulfur dioxide under the same conditions. So please come with me.
Binnacle project.
The situation is similar to the previous section, as they are asking us to calculate the volume of this substance. The pressure of the laboratory is 2 atmospheres, and the temperature is 25 Celsius degrees, which means 298 kelvins. We are using the same formula. Pressure multiplying volume equals the number of moles of sulfur dioxide, multiplying Rydberg constant, and multiplying the temperature. And we are proceeding just like in the previous section. 1.5 moles of sulfuric acid. This conversion factor will help us to move from moles of sulfuric acid to get into moles of sulfur dioxide. Sulfur dioxide. There comes the conversion, the stoichiometric coefficient, 2 for sulfuric acid and also 2 for sulfur dioxide, which means that the stoichiometry between these two substances is 2 by 2. And also here we are stopping the train because we want to obtain moles of sulfur dioxide, not grams only moles in order to place this data here. And 2 divided by 2 is 1, which means that we will also obtain 1.5 moles of sulfur dioxide. And there comes the solution. Pressure 2 atmospheres, multiplying the volume of sulfur dioxide. Number of moles of sulfur dioxide, 1.5. There comes the Rydberg constant, 0.082, multiplying the temperature, 298 kelvins. Now let's use the calculator and the problem will be over. 1.5 multiplying 0.082 multiplying 298 and divided by 2. Check out if you obtain 18.33 liters of SO2, sulfur dioxide. And our problem is over. It has been a very cute stoichiometric problem, don't you think? As the substance they gave us was in the form of a dissolution, not in the form of grams. And on the other hand, the products they wanted us to calculate were not in the form of grams, but in the form of volume. So, hope you have understood every steps we have taken in order to master stoichiometry. Goodbye. And now, watch a theory video if you think you've gotten lost in some aspects, or skip to the next exercise to continue climbing. And as always, like, turn on notifications and comment. See you soon!